On problem 129, we're taking a look at several graphs, and we're going to try to find the equation of them. So for problem A, I'm looking at this one, and I have the graph coming up to 3. The lowest points on the graph are 1, and what that can help me figure out then is where my midline is located. My midline is going to be halfway between there, which is now at 2. So that midline, which is my k value, is at 2. Once I know my midline and I know how high up and down it goes, the distance here, which is the same as that distance, is now a 1, and that is my a value. So the amplitude in the a value is now 1. I can also figure out that the period of this graph, the distance between cycles, that distance there, or the same as the distance here, the distance it takes before it repeats itself, that distance is going to be 2 pi. A couple of different ways I can look at that. One of them is if I take a look at this purple mark that I just made here, this distance right here is 2 pi. So the distance from the bottom to the bottom again, where it would repeat itself, is also the same as 2 pi. Or from that dot there to the same dot where it would repeat itself is 2 pi. So I now know that the period is 2 pi. The last thing I need to take a look at is where I want to start this graph. I would like to do this as a positive sine graph, so I'm going to start on my midline, going up. That makes it a positive sine. That h value is right here. Since that's halfway between 0 and pi over 2, that is an h value of pi over 4. I can now write my equation. Y equals, my a value is 1, but I do not need to write a 1 times sine, so sine x minus pi over 4, and then plus my k value of 2. So there's the equation for problem A. Repeating that process for problem B, I'm going to take a look at how high up it goes, and that's up here at 2. How low it goes is down here at -1. And then that'll help me determine where my midline is located. And my midline is right here, halfway between there. That k value then is at 0.5. If my k value is 0.5, that means the distance here then, which is my amplitude, is 1.5. So I now figured out a is 1.5. Again, taking a look at the period, lowest point here to lowest point here, that is a distance of 2 pi again, from a negative pi to a positive pi. So that is a distance of 2 pi for the period. The last thing I want to do again is determine my h value, and to start with a positive sign. If I want to make this a positive sine graph, I will start on the midline, going up. So my h value now is a negative pi over 2. That now makes my equation y equals my a value of 1.5 times the sine of x minus a negative pi over 2. Minusing a negative makes it now a positive pi over 2 plus my k value of 0.5. And there's the equation for problem B. Problem C, once again, taking a look at how high up or down the graph goes. We're looking at that being the top. That's as low as it goes there. And my midline being right in between is there. My k value then is 2. Amplitude is now 1. Distance between here and here That is a distance of 2 pi once again. That one might be a little bit harder to see, but again I can move that over here and say, oh yes, that is that distance of 2 pi. This problem as well is a little bit different than the last one, simply because of the scale that they are using. So if I look at a distance from 0 to pi, they are using sixths of pi. So each line is a sixth of pi. I'm going to need that now for my h value. So if I want to make a positive sine graph, there's my starting point on the midline going up. But to locate that h value, I'm going left of my y-axis, 1, 2, 3, 4, and 5 pi over 6. And since it's left, it's a negative. So that is now my h value. I now have an equation of y equals my a value of 1 times the sine of x minus a negative is x plus 5 pi over 6 plus my k value. And the last problem, problem D, once again you can see it's scaled the same way as the last one on your x-axis. My top goes here, my bottom is here, which means then my midline halfway between those is going to be right on those dots. So I have a k value, my midline, at -1. My amplitude then goes from -1 to +2, or from -1 to -4. So the a value here is 3. So choosing now an h value, if I want to go with sine, a positive sine, I go from my midline going up. And just like in problem C, I need to look at what the scale of my x-axis is located here. I have 1, 2, 3, 4, 5, 6 lines to get to pi, so it's divided into sixths of pi, which then means that this dot right here is at 1, 2, 3, 4 pi over 6. So h equals 4 pi over 6. That can be reduced down to 2 pi over 3. The period, once again, is going to be 2 pi. So my equation is y equals the amplitude times the sine of x minus 2 pi over 3 minus 1. All these graphs could have been done as cosine graphs as well. I just chose to keep them all as a positive sine graph.